I'm back, and I've kind of like made some more variable names and documented them, so I'm ready to work with those variable names. So right over here, where we have the size of a single tile, let's see, it's measured in pixels, and it's as seen on the destination. So the destination viewport, that's the viewport that we're actually looking at in the game. So the width and the height, so this stands for, I believe, tile pixels 0, and 0 being viewport 0. And the width and the height, so WID for width, HIG for height. And right here is where we're going to calculate the max and min values for the coordinates that are local within a tile. And let me go look up my reference here. So I'm going to call var, and it's going to be tinco, and then it's going to be, I believe, x0. So is that going to be 7? Yeah, tinco x0, and that's going to be 0, because the local coordinates start at 0, 0. And then for y, it's also going to be 0. So this is the local or tile internal coordinate x0, and x0 slash, or x0 is the min, right? So, and then the same thing here, so I'm just going to make little comments here. So same thing, except this is y0. We'll copy all this, and because we're running out of room and we got to assign this to something, we can say tinco.x, you know what, we can say like this, right? So we're gonna take this and we're gonna re-abbreviate it just so that this comment doesn't take up as much space, because this is gonna be our max values, and it's just gonna be the widths minus 1. Size of tile measured in pixels. Yeah, so we're gonna take the size of the tile. If it's a 64 by 64 tile, that means that you can go from 0 to 63. Okay. Oh, there we go. So right here, we have our min values for the local coordinate, and then we have our max values for the local coordinate, and these are the local coordinates within the current tile you are scanning over. And that's going to be important if you want to figure out where to draw a black border around the current tile that is being rendered. So I'm going to take these and I'm going to color them. Just in case I've referenced them already. I don't think I have. And then down here, where we are using LDX min and LDX max, those variables, we have absolutely no use for them, because those are the local coordinates of the, well, I mean, LDX min and LDX max are the bounds for the local coordinates of the full viewport, and this is not what we want. We want, let's see, so this is tinco x0, so the min, and then tinco x1 for the max, and then right here, it's like that. Right? And same thing with here. So we'll take the so if our local tile coordinate is out of, these are the upper bounds here. So actually no, this is okay, just refactoring. Okay, so this is the min bound, and this is the max bound, and these are inclusive boundaries. So this local coordinate needs to be Oh, so I made a little mistake here. This local coordinate can either be greater than or equal to the lower bound, and this local coordinate can be less than or equal to the upper bound. Oh no, it was because I already have the exactly equal case here. That's why I didn't do that earlier. So I'm gonna get rid of that greater than or equal to. The idea here is that I want to look at the case where I'm going to draw the black line, look at the case where I'm not going to draw the black line around the border, and the case where you screwed up because this case or that case should have already caught it. Okay, so let's keep on refactoring. With this, we could copy this whole chunk, paste it here, and then change the x's to y's, or we could refactor it one more time manually just as a redundancy. So I think I'm going to do it as a redundancy. I'm just going to type it again and kind of get used to the variable names. So the tile internal coordinate y, lower bound, and tile internal coordinate y, upper bound, and the tile internal coordinate y-axis, tile internal coordinate y-axis. So here's the local y value within the tile and the upper and lower bounds. And if we are exactly on the upper edge or the lower edge of that tile, within that tile, we're gonna change our RGB color to the black color to draw a black line around that tile. Again, so we have the min and the max. So tile internal coordinate y min, the min bound, which is inclusive. Tile internal coordinate y1, which is the maximum bound, also inclusive. And then tile internal coordinate y, y like that. And then tile internal coordinate y like that. So we can make sure that we've type that correctly, and we can see all four light up here, and then we should have all four light up here as well. And we'll look at the bounds. So we have 2 here, 2 lighting up here. So if we go over here, we should have the same kind of analogous lighting up to make sure that these 2 sections of code here and here are completely complementary, right? So that by typing it twice, we kind of get a little bit of redundancy as we're writing it, and a little bit of it's more likely we're going to find errors if we do it by hand once, do it by hand again, and then check to make sure they're equivalent. I mean, you don't have to do it that way. If you want to save time, just copy, paste, and change, whatever. I'm just showing you how I did it and why I did it that way. Okay, so I think we have everything we need to make that black border. Maybe we want to like look over this really quick and see if we're missing anything. So this is the local coordinate within the viewport, and we're going to take the current tile x times how many pixels a tile takes up. So these are all the pixels that are used up, or you could say how far away the let's see. Is that right? Yeah. So this is kind of like this value is kind of like LDX, except it snaps to the nearest, but it snaps in increments of full tiles, if that makes sense. So it's kind of like a floored value in a sense, and then subtracting the local coordinate of the destination viewport, and we're kind of getting a remainder here, right? So this value will always be less than the size of a tile, and same thing with this. And actually, why don't we add that error checking in as well? And the reason for that is the error checking, first of all, it's nice to be give our code a little bit more robustness in terms of finding things that are wrong, and it'll also help self-document this logic a little bit better. So I'm going to put a breakpoint right here and here, and we're going to TP0, so this is the width of a single tile. I want to just double check that, because I could be wrong about that. Control 0, gonna clear that. So TP0, right here, tile pixels dest, size of a tile measured in pixels as seen on the destination. Yes, so this is the size of a single tile. So this is tile pixels viewport 0 width and height. So I just wanted to make sure that was correct. I'm going to highlight both of these so that I can scroll back down really quick and see where they are. I'm also going to copy one to the clipboard. And we had our breakpoints right here, so I can see them there. And now we're going to just add a little formula here, or a little error check. So if or actually, maybe we're already checking this. Maybe we don't need to. Yeah, I guess we already have the, because we kind of already did that, because the bounds right here. But you know what? I am all for being redundant, even though it's like we already kind of wrote this error check down here, just in a slightly different form. But, you know, I have nothing against. I know some people have something against, you know, cluttering up their code with like a lot of error checking, right? Because then everything gets like really long, and then it gets hard to like figure out where the main logic is because you have everything interlaced with error checking. You know, you gotta decide what's more important to you, whether the flow of the code is more important to you, or if just having sanity of mind of knowing that your code is correct. I would rather have sanity of mind. Obviously, I do have some vanity aspects where I try to make everything lined up and look nice. But as far as removing error checking to make things look nice, no. I would rather error check as much as possible. Okay, with that said, we know that if it's less than 0, that would be wrong. Or is greater than or equal to the width, right? Because if the width of a tile is 64 pixels, then this value needs to be no more than 63. So if this is 64, which would be greater than or equal to 64, if the tile is 64 tiles wide, that would be wrong. We would be out of bounds. Now, if we want to, maybe to save some space, because all I really want to do is detect a problem. Maybe we don't care if it's on the X or Y. We just want to check for the problem once. So we could do something like this, where we just put both of these checks and consolidate them into one if statement, right? So TP0 height, right? So checking both the X and Y, and then here, right here, we can just throw, and then we can just have X or Y is out of bounds, right? And we're not going to specify which one is out of bounds, but we just want it. The most important part of the error is just to grab your attention, grab the human's attention, the programmer's attention, let them know something is wrong, and let them be able to find the source of the problem. So the error message itself really is not that important. It's just important that the error message happens and that the error message is unique enough to be able to easily hunt down. That's a highly opinionated thing, but that's how I think about it. Okay, so we have this extra error checking just to give us some sanity of mind that these internal tile coordinates are correct. So that way, when we're doing some math with these, we can be a little bit more certain that the values we're working with in this block are correct. With that, let's give it a run, see if it works. I'm a bit nervous because we've changed a lot of stuff around, so let's give it a run, and we screwed some shit up. And actually, so this is interesting. So that error checking code I just wrote, oh, you don't see that. So the error checking code I just wrote says uncaught exception and TINCO and then XY out of bounds. So, so that crazy error checking I wrote, just got tripped. So it's like, So it just kind of paid off already. Um, so yeah, that's so if I hover over these values, I'd say somewhere I have fucked up greatly because I have for the local coordinate on the x-axis, I have a negative 577, and for the y-coordinate local, I have negative 11,054. So I would say that that tells me um, that well, it's negative, so I think maybe up here I may have done this in the wrong order. I think maybe I need to flip this equation around. Let's think that through again. Well, if we have the local coordinate, it needs to just be chopped down. So actually, no, this should be on the correct side. But LDX and LDY are 0. Tile X, 128. Ooh, okay. So are there 128? Oh, you know what? It's I'm gonna guess this tile value is the actual tile on the this is the tile value on the source viewport, but I want the tile value on the destination viewport, if that makes sense. TX. Yeah, so let's take a quick look at and then this width. Like, what the hell is that? Why is my width in height? Why are they fractional, right? Like, these shouldn't be floating points. These should be whole numbers. So so we got some problems here. Let's I'm gonna keep the debugger open so I can reference it. Obviously you can't see it right now, but we're gonna take a look and see where we screwed that up. So we're saying that TX and TY are, we want the coordinate of the current tile on screen, and it seems like these are the tile, the XY value of the tile within the data. So TX, right, yeah, that would make sense because this says source X and source Y, and this is TX, TY. So this is the tile on the source. So tile on source, VP, that would be VP1, yeah. Okay, so with that, SRC, I'm gonna do it like that so I can. Okay, so we gotta reevaluate our life and think about what we screwed up here. Pour some more energy drink and think about this. Timer's still going. Okay, so we got a lot of stuff we're working with here. So maybe a note that this is not the value of the current tile, the pixel dx dy is inside of, right? It's just a little note. But I am going to make this red. So just to grab my attention. Maybe move that like that. Exclamation mark. Okay. So tx ty, this is not the value of the current tile the pixel dx dy is inside of. This is the pixel value on the source. In other words, the tile value. well, not the tile value, but the tile's coordinate, the tile data. This is the location of the tile data we're sampling from on the source image on our data set. I gotta stop recording the video and restart.